All right, we made it. Sequence and series. Yeah, this game can be really tough, or this game can be not so bad. It's kind of up to you. If you stick with it and you stay on the ball and you don't jump behind or fall behind, I think you'll find success through this. It's a puzzle. It's a big old puzzle, but I know I babble on about puzzles and games and stuff like that, but this truly is. Like patterns. Do you see patterns? So let's kind of jump into it and see it. We're just going to, as we call it, it's an overview. We're going to talk about sequences, and then we'll move into series, and it's going to be up to you to know the difference between the two of them. But let's start with sequences. And this is what a sequence would look like. It's just a sequence of numbers. 2, then 5, then 8, then 11, then 14, then 17. Do you see the pattern? Do you just see the pattern with the numbers? Do you see that we're just adding 3? Every number is 3 bigger than the previous. Each number, individual one, is called a term. There's a term. There's a term. So just making sure we're all using the same vocabulary words, you know what I mean? Those are terms inside of a sequence. Inside of said sequence. So this is a sequence of numbers, and inside of the sequence of numbers, we have terms. Or a sequence, it's a list. All right. Now, the way that we're going to write this in general is we'll say it's our first term is a sub 1. You could make it a sub 0. You could start at 0. Shoot, you could start at negative 15 if you felt like it. But I don't know, I like starting at 1. And then 2. And then 3. And then 4. And then 5. And then 6. And then let's stop writing it. And then I struggle to write curly braces on the right-hand side. So if they're bad, just laugh. Okay. So that's how they're going to be. It's just written. It's just a list of terms. And then if we were to continue going with this list, then we get up to n minus 1, a sub n, and then we'd be at the end. And a short way of writing this would just be to write it like this. Curly braces with some a sub n in there. I mean, it's really writing this. We're not going to write this. N equals 1 up to infinity if it goes on forever. But another easier way of writing that is just to say it's just a sub n, and then it's implied that it continues on forever. And our sequences will traditionally go on forever. Okay. Do you remember from past classes what these numbers are called? Do you remember what these numbers are called? Those small numbers are called our index. It's our index. Remember our sums, which will start to happen. I'll let you in on the secret. A series is taking a sequence and adding up all the terms. We're not there yet. Where we'd say it goes from k equals 1 up to n. Just like these are indexes or indices. And these are indices. Soon we'll start writing it with the big old sum thingy. But that's not yet. That's for a series. So, excuse me. So let us take a look at what we're going to do. So there's a couple different ways that we can do this. We have something called a recurrence relation or an implicit formula. So let's call it this way. I called it a recurrence formula, but a recurrence. Now I got to make sure I spell it right. Relation. So we can write this out in a couple of different ways. So one way we can say it is, all right, a sub 1 is equal to 2, right? That was our first term. So it's saying, hey, whatever your first term is, good to go. And then what we can say is, well, the next term, a sub n plus 1, is equal to whatever the previous term was, plus 3. Okay. And that's true for any n is equal to 1, 2, 3, 4, ... Now remember, the n's are down here, or our subs are down there, how we're going to sub this in. So if we look at this, we're like, all right, so a sub 1 is equal to 2. What comes after 1? 2. So that's saying, we're saying n is equal to 1 right now. So what's 1 plus 1? 2. That's why I got 2. And then if n is equal to 1, that's just a sub 1. But we know a sub 1, it's 2 plus 3, which equals 5. So now we have a sub 2 is equal to 5. Now we jump it down. We're like, well, if a sub 2 is equal to 5, what's a sub 3? Well, that's your a sub n plus 1. This is your a sub n. It's saying, take your previous term, pop it in, and then add 3. And then we get 8. So we have a sub 1 is 2, a sub 2 is 5, a sub 3 is 8, and then I think you catch the pattern, yeah? So then we ended up with our list, our 2, our 5, and then once we catch it, we're like, well, I don't need to rewrite that anymore. I can just start writing them, 11, 14, 17, 20, 23. Come on, man. But I think the list is good, but those are the same numbers we had from up above. So there's a way of writing it in what we call a recurrence relation. This trips me out. I struggled with it myself. So hang on, do your best. But we could also see it another way. We could see it in a much more algebraic way, where we could just set this up and say, well, dude, whatever the term we have, well, that must have come from 2 plus what? And I claim it to be 3 times n minus 1. Well, would that work with those numbers we have? Let me pull this out. Let's just see. And these are the games, like, it seems like I'm just kind of pulling it out of nowhere. And I kind of am. So this is not a recurrence relation. I'm trying to find some sort of pattern. We're going like, well, wait a second. The first number is 2. And then this is also the first term, second term, third term, fourth term. So that's n equals 1. Now, how do we get something with n equals 2? Well, we know the gap is 3, don't we? We know the gap in between each and every one of these. 3. Huh? 3. There's a gap of 3 in between each of them. So we're like, well, dude, if I just pop in a 3 here, and then what do I need to multiply to make that thing equal 1? Right? We just need to add 1. Isn't that just n? But it's not n. We're looking for, how do we get, like, let's go with an example. How do we get a sub 2? We're going to take 2. Now, n is 2. You got to subtract 1 from it. So we find out a good recursive formula would be a sub n is equal to 2 plus 3 times n minus 1. I know I'm not doing the best jobs of explaining it. We got to get in there and try it ourselves. But, I mean, if you check this thing out, let's plug in any freaking number. Let's say a sub 5. That's 1, 2, 3, 4, and 5. 14 is the 5th term, right? That's n equals 5. So we'd say it's 2 plus 3 times 5 minus 1. So that's 2 plus 3 times 4. What's that? 14 is a sub 5? What's a sub 5? Hey, it's 14. We got it. So we're looking, and there's a direct, like, algebraic relation that we can come up with, and sometimes there's not. Try and do that with the Fibonacci sequence. That stuff's not going to happen. I'm just telling you, it's not going to happen. You're not going to be able to find some algebraic term like this that's just going to work out and plug in the end. So sometimes it works, sometimes it doesn't. Sometimes we got to deal with this nonsense. Back here, this stuff, a recurrence relation, where I had to write everything or we have to write everything as such, where we're just going to know, well, I can tell you how to get the next term. As long as you give me the first term, I can give you the next term. That's a recurrence relation rather than just some algebraic equation that's going to pop it out for you. So there's the beginning. I know it's a lot. It's confusing. What the frick is going on? Let's get into some what we call explicit formulas. And we're going to go through and we're just going to write out some sequences. So this, excuse me, am I dying or something here? So this first one was to give you a lot of information. Kind of scare you. Next one, we're going to start just messing around with it. We'll make it a little simpler for you, okay? We'll move into what this means. And yeah, we'll hop to it. All right, see you in the